Okay, hello. Today we are going to be discussing the neuromuscular junction. The purpose of this is to send an electrical signal from the brain to our muscle fibers to create a movement in our muscles. So the initial phase will start with a signal coming down from our brain. It'll reach the axon terminal, or the end of the axon. This signal will then allow for the calcium gates to open, allowing calcium to flow into the axon terminal. This addition of calcium will push the vesicles out to the ends of the axon terminal, and ACH will then be released by the vesicle. The ACH will then bind with ACH receptors on the muscle fiber. Once these bind, this will open up sodium gates that allow for the passage of sodium into the T-tubules. Once the sodium is in, this will allow the sarcoplasmic reticulum to release its calcium into the T-tubules. This excess in calcium will then will distract the tropomyosin by attaching to the troponin, and it will allow the myosin and actin to connect on both ends. This connection will then cause the muscle fiber, or the myofibril, to contract. And when it's contracted, this causes the contraction effect. This process will then continue along the entire muscle fiber until the motion is completed. Once the contraction is done, the signal will voluntarily end from the brain. Once this signal is done, the calcium pumps will get rid of the calcium in the axon terminal. ACHE enzymes will then go and remove the ACH from the terminals. Sodium pumps, which are not shown, will remove the sodium from the sacrolemma and the T-tubules. And calcium will then be returned to the sarcoplasmic reticulum. This loss of calcium plus a little of ATP will allow for the tropomyosin to re-interfere and block the myosin and actin, causing the myofibril to retract back to its normal position due to its elasticity. And this resets or relaxes the neuromuscular function. Thank you.